for us and for researchers and for the people outside. So that's my interest. And let me start. So if there are any questions, you can pause me and ask some questions, or we can have it just for logistics. We can have it at the end of the session. Can you see my screen? Can someone message or say that if you can see my screen?
Yes, sir.
Yes, sir. Then we'll get started. Okay. So in the next 45 minutes, this is the outline of what I'm going to talk about. I will talk about why safety is important. I'll just switch off my camera just so that it will save some bandwidth for someone listening on mobile. So I will talk about why safety is important. I'll also say, why driver assistance systems are a factor in this road safety. And then I'll talk about how AI can be used for, road safety. And I'll also talk about the work that we have done in India, from India, in the academic, research on how it can be used. And that's the, next 45 minutes of my plan. Okay. So I want to introduce, I know that this group is of students from ECE, and still it would be interesting for someone who is heard about this topic and or is thinking about something on artificial intelligence or machine learning. Right? I kept this talk fairly lighter so that there are no equations. There are so people can listen and be just interested in this curious in entire topic. Okay. So I wanted to set some definitions for our discussion. So in this next 45 minutes or 1 hour, whenever I say it's AD, it's called autonomous driving. This is or driverless cars, as popularly known, and ADAS is driver assistance systems or advanced driver assistance systems. Okay, so that's those are the acronyms or abbreviations that I will use. Okay. So what is when there are cars that are coming out with driverless features or no steering features, why driver assistance? Because if you see driver assistance systems help prevent accidents in existing cars, and they can help prevent accidents. They reduce human error because most of the accidents are contributed by human error, and so if systems can reduce this human error, it can enhance road safety, right? So the humans are the single biggest reason for any accidents in several countries, and these systems can lower or reduce the injuries if any collision has to happen. Okay, so therefore, if by doing all this, you may improve the survival rate. When an accident, if and when an accident happens. So that's the basic definition of AD and ADAS. Okay, so there is. Society of Automobile Engineers is the international society that has developed, that has defined 5 levels of autonomy. So 0 to 5, where 0 is only humans driving a car, and 5 full autonomy is no human is driving the car. This is where you would have seen some videos or some news articles which say that there are cars that can drive without any human input, and there are systems that are available and that can drive by the cars can drive by themselves. That is full autonomy. Okay, so where are we now? We are somewhere between 1 and 2, or mostly I would even say 2 and 3. Most of the cars that we have seen in the past are all modern vehicles, and we are seeing a transition from 2 to 3 now. Okay, so that's where the tipping point is, and you would soon see a lot of adoption of technology that can get us to 3 or full 3 or full 4. 4 is fully autonomy. There can be a human whenever there is a control that needs to be taken, right? And 5 is already demonstrated in some specific conditions, or in countries like the US, where there is enough data and there are structured driving conditions. So 5 is indeed proven, and there are systems that exist for 5, but there are very few. When I say we are presently in between 2 and 3, I'm talking about mass scale or in large scale. In India, definitely we are in between 2 and 3. So here are two examples of driverless cars or self-driving cars. One is from Tesla, the other one is from Mobileye. Yeah, I have given the YouTube links for those interested, so you can take a look at it, and you will see that in this case, the Tesla will drive in this road in San Francisco without any input from the driver, just from the map, and it can detect all that is happening around using the cameras and other sensors and other data that is available. So it is very important for this car to have the map and to also have sensor that can detect things in this surrounding for it to be able to navigate. And a similar feat has been achieved from Mobileye, where the car is shown driving in the streets of Israel. Uh, without any human input. So you can take a look at this. These are all available on publicly on YouTube. This is so full autonomy with level 5 is indeed possible, but in very small circumstances or situations. It is not completely widely deployed yet. So why do we talk about, why do we have to talk about, why do we care about safety or road safety? Because road safety is one of the big societal problems. One some of us or most of us may have someone in the close family, or in the neighbor family, or someone who has been impacted by some road accident or otherwise, right? So in worldwide, this road accidents alone kill about 1.35 million people every year. And in the age group of 5 to 29, which is very, very critical or a crucial, productive period of a human life, and that's the killer age group. Not anything, not any other thing that you can think of. So just imagine, for no fault or their fault, people, a huge number of people die in this age group. Okay? So that's just a graph that shows, and it is, doesn't seem to be reducing to the, satisfactory extent. In India alone, 150,000, sorry, that should have been 1.5 lakh people get killed every year, and 450,000, 4.5 lakh are crippled or impacted by the accident. And most of this death is in the age groups 18 to 45. So, and the cost of an accident has been estimated. It's about, in case of a death, an average, estimate is 91 lakhs. And for every injury, it's about 4 lakhs, right? And together, if you see, it's about 4.3 lakh crores in India. That's the cost of lives lost or people injured. That's the level of impact it has. The other interesting statistic is India has only 1% of the vehicles in the world. It includes cars, buses, and every other vehicle that you can think of. 1% of the world's vehicles, but India has 11% of all the road deaths that in the world. That is staggering if you think of it. So therefore, it's a big societal problem both for the world and for India. Okay? So if you get into the, if you look in how safe are Indian roads, there has been a lot of mission mode activities on enhancing road safety, and that's also the reason there are the fines have been increased for road safety. If you are wearing a two-wheeler or a bike, you should wear a helmet, and if you are if you are driving a car, you must, not just the driver and the passenger nearby, but also people in the back seat must be wearing seat belts, right? So the rules have been amended both for everyone's safety and for the country's progress. So the road safety is a severe problem in India. There is a statistic that says a death happens every 4 minutes on an average in India, right? By the time by the time we talk, this talk finishes, almost 17 deaths would have happened. That's the level of accidents that happen in India. And as I mentioned earlier, it's 3% of the GDP every year just due to road deaths. Okay, and we have India as a country have set targets to reduce this, or to reduce this impact of road accidents and people dying. We are still unable to meet that goals yet. So there is this example that says we lose one city every year. That's the harshness of the reality. We have had different goals We want to reduce this number of road accidents by 50% in by 2025. We have a new road safety board, and there are comparisons of how road accidents in India compared to other well-known causes. Right, there are different kinds of comparisons that are made. Okay? So that's about that's what. So hence, road safety is an important aspect of that we should acknowledge. We may not be able to see that in big news, but that's the seriousness of the problem. That's the road safety. Okay? Now, if you talk about how is safety in automobiles, how did they even evolve, right? As a the airbag and the braking systems that we are aware, they were all developed in the 80s. If you really see, right, that's when the technology was developed. Okay, the deployment happened over time, but that's the initial. Just imagine it is almost 45 years back. These technologies were ready, and the side airbags were ready 35 years back, 1990s. Okay, and adaptive cruise control and other features are all progressed, but the deployment and availability of these safety systems in the automobiles, be it in other countries or especially in India, have taken a long time for adoption. And so what we saw, the side airbag and this airbag, we now have a mandatory law that says all the new cars in India must have 6 airbags, which is a very welcome move. Although the cost of the vehicle goes up, it increases the safety of the occupants inside. Okay? And there are multiple other technologies that have been demonstrated. Automatic parking that you would see probably in the news, and there are so this is autonomous driving, that is 2025, but that's level 5 that I talked about, and it's been there for in specific circumstances or situations or specific parts of the country, like in the US or Israel and other places. It is available, and the mass scale may take some more time. Okay, so we as a generation will witness this huge transformation that's going to happen in this area of mobility. Okay? So what can we do? The autonomous driving is still far away. How can road safety be done? Through our driver assistance systems. There are what is driver assistance systems? As I mentioned earlier, a better definition would be it's a vehicle based safety system to improve road safety that helps you avoid a crash, or mitigate a crash when if it happens, or even after the crash the occupants are safe. That's what the purpose of an ADAS system is, or driver assistance system is. Okay, there are multiple sensors that can be installed on a car. For example, I'm talking in case of a car here, there could be cameras, there could be lidar, there could be radar, there could be ultrasonic sensors on side cameras and IR cameras. All those can be installed, and all these subsystems, these are all subsystems that can work independently and provide the safety of the occupants. Okay. So there are as I mentioned, right, there are these individual technologies that are small, independent, but they can together make the car drive autonomously. Okay, and there are when you put them all together, you can create a self-driving system or an autonomous driving system. So the key thing is you should have these sensors installed. They help you perceive the scene or the environment around this vehicle, and then there is a planning. So perception, planning, and control are 3 important things for autonomous driving. So perception is achieved by these various kinds of sensors. Planning is through your algorithms that will take this input from the sensors and create a path. And control is when you apply either throttle or brake or other inputs for steering the vehicle. So these 3 components, planning, perception, planning, and control, together contribute to the autonomous driving. And in perception, these are multiple sensors that you can see. So together they contribute for the safety of the vehicle and the occupants inside the vehicle. Okay? There are multiple. If you talk about driver assistance systems or ADAS, the features are different. Companies call it different way. There is no one single list. So the topmost things that come up when you say ADAS are lane departure warning, lane keep assistance, which means you can put the vehicle in the same lane and it'll keep the lane. It will not drift out of the lane. And there is forward collision warning, which means if there is a vehicle in front and if you are getting closer to that, the system will detect that and it will give you the forward collision warning. Okay. And then there is a pedestrian warning system. It's about, if there is a pedestrian or a human in front of the vehicle that you are driving and in the lane, then it will give you a warning that there is a pedestrian you may hit. And this is important because people get distracted or people do not see the lane all the time, or either they are tired and therefore such kind of vulnerable road is they call them, we call them VRUs. If you are, if there is a chance of any collision of the pedestrian or a two-wheeler rider, for example, there are these warnings and there are lives at risk. So therefore, pedestrian warning systems are helpful. And there is a traffic sign recognition. It tells you that what speed is the traffic, this road is supposed to be, and what speed are you driving. So that requires a traffic sign recognition to be fixed. Then there are other advanced ones which are camera, driver facing with driver facing cameras or sensors. You can find out if the driver is drowsy. The drowsiness could be due to some drunken driving, or it could be also because the person is sleepy. All those things. So if the person is tired, the drowsiness, so there are systems that can detect if the driver is drowsy, and it can also detect if the drivers are, you can also have a higher, next level where you monitor the driver, which means, if the driver is on the phone and therefore distracted, or if the driver is smoking, or if the driver is not paying attention to the, road ahead, those can all be monitored using a driver monitoring system, right? There are lots of other bells and whistles that you keep hearing from the new cars, especially the surround view camera, blind spot monitor, and adaptive cruise control. All these get bucketed under or called as ADAS features, but these are one can talk about this. But in this talk, I'll talk about this top features that are the ADAS features, right? The lane keep assistance systems, or the collision alert systems, and the driver drowsiness. I'll just briefly talk about what they are and what kind of systems are available. Okay. So the collision avoidance system, which gives you, so this is the collision avoidance systems. It can give you lane departure warning, or a forward collision warning, or a pedestrian warning system, or a pedestrian collision warning. All these are a collision, possible collisions. So there are systems that can do this. Is called a CAS system, collision avoidance system, and this is called a driver monitoring system, or a DMS. Okay. So the lane departure warning, I'll just briefly talk about it. So if you are driving on a lane, and if there are lanes marked on the road, if you are crossing a lane, you as anyone in the driver is supposed to indicate to the vehicle behind that the vehicle is switching lanes. So which means you have to put on the indicator either to the left or to the right when you switch lanes. That is the expected driving practice. When someone is not doing that, it does not tell the driver behind the vehicle that this vehicle is moving. So what happens is accidents could happen, and therefore there could be loss of either property or lives. That's why the lane departure warning system is important, and it also is helpful, especially when the driver is sleepy or distracted. Because what happens is, when the driver is not looking at the road ahead, the vehicle drifts lanes. And you can, when especially the person is sleepy or looking at the person next in the cabin and talking, then this kind of departures happen on the lane, right? So collision avoidance system helps, and the driver monitoring systems also help, right? So collision avoidance systems, there are some of these. These are, you would see this. You can even get it instrumented in your car or a vehicle. There are these are some of the companies that are well known to have a collision avoidance systems. This involves a camera mounted on the windshield of the vehicle. It could be a car or a bus, and the camera monitors every second of the, or milliseconds of the vehicle, and it has access to the speed of the vehicle, and it has an AI algorithm inside. It has those algorithms help detect whether there is a collision that's going to happen, or if the vehicle is drifting lanes, and therefore it gives a warning on this this display that is mounted inside the cabin near the driver. Okay. So there is a visual warning and also an audible warning typically given. So if there is a lane departure, the lane signs are lit up, or if there is a pedestrian, the pedestrian sign is shown, and there is also an audio alert given. Typically, these alerts are given 2 seconds before a possible collision. And there is enough research that says that if a driver is given a warning 2 seconds before, that and the driver can react, take some corrective action like apply a brake or reduce speed, accidents can be averted. So that's the most of these collision avoidance systems have a warning that is given typically 2 seconds before a possible collision. Okay? So that's a collision avoidance system. And the driver monitoring systems, there are some of them in the market. This is a camera looking at the driver, and this is typically an IR camera, and the cameras can detect multiple states of the driver, whether the driver is sleepy, not paying attention, smoking, or drowsy, distracted. All those are possible. So these are some of the companies that offer this driver monitoring system. The ADAS in India started with I would say the public view of ADAS started with the MG Gloucester, which which claimed to have a front collision warning, and that's I would say is the first feature that became available for the consumer market in India. Okay, and the XUV 700 recently launched also has this ADAS technology. And so you will soon see multiple other car models coming up with this ADAS features in India. So watch out for this. You or someone would probably be having this kind of ADAS technologies in their car. Okay. So how is road safety possible with AI then? Okay. So I talked about safety, the importance of road safety. I talked about some of the technologies that can give safety as a or that help give safety. And now how can AI help in road safety? Okay, so this is remember the 5 levels of automation that I talked about. This is 0 no automation to 5 full automation, and as I mentioned, so we are somewhere in between 2 and 3, right? Where we can take the control of the car. For example, some of the cruise controls are I would say partial to conditional automation. Okay, so that's where we are. And some of the newer cars have cruise control, which means if you are driving on a highway and you do not have, if you do not see much of a need for pressing the accelerator, you can set the cruise, and the vehicle will drive at the speed that you have set. And the moment you press a brake, the cruise is disengaged, and so you can take control of the car. Until then, it will keep at the same speed that you have set. That's a cruise control, right? So that's possible, or that's coming up in the Indian versions of the cars. That's why it's between 2 and 3. So controls like this will become available in the public, in the open, in the mass market. Okay. So here is the SAE, or the Society of Automobile Engineers view of automation. Here is a different view from the AI world. So instead of 0 to 5, we have a L0 to L5. Where L0 is similar to SAE, where all cars are manually controlled. Okay, and nothing is turned is in control of the AI. Whereas L4, L5 are fully autonomy, where AI or artificial intelligence is fully responsible for driving a vehicle or a car. Okay, and L1, L2, L3 are human-centered autonomy. In a way, this is similar to similar to the SAE, but this is primarily defined with AI in mind. Okay? Whereas the SAE engineers do not talk about how it is implemented. The AI perspective says that AI is responsible for L4 and L5. Okay? So how is ADAS possible with ADAS? Presently, ADAS is possible, and in future, AD will be possible with AI. This is it's typically done with multimodal sensor vision, as I mentioned earlier. A vehicle must have different sensors installed, and all these sensors must inputs are taken into a typically a neural network, a deep convolution neural network, or an advanced network that takes all these inputs and makes some decisions. Here is one possible here is one illustration of it. So you have multiple cameras and sensors are mounted on a car. There are all kinds of neural networks that calculate, or these are subsystems that calculate only one aspect of the problem. So whether is there a pedestrian, it says there is an object ahead, there is a pedestrian, it's a pedestrian. That pedestrian is how far ahead, right? So this is all, done by a compute. And all this is, and in addition, we also have side, rear, night vision, IR cameras, front stereo cameras. So this pedestrian is sensed by this car in milliseconds or microseconds of, this person coming into the view of this car, right? So therefore, all of this is possible because of the algorithms and the compute capability that is available as a CPU or a GPU on the car, right? If not for the development of this hardware compute, we would still be far away from this kind of a autonomous driving car vehicle. So all this is being enabled by the development of sensor technology, the neural networks, and the entire machine learning community, and the hardware community, and the silicon community, which developed the compute capabilities, and everything becoming possible in milliseconds or microseconds. So the lot of technologies have come together to make this vision possible. So in for AI and machine learning, anyone who has dabbled in this space will understand the importance of data. So here is one view of how this is possible. So sensors and data, all of them, or the raw data comes, and the using this, there are different kinds of fields that use this data and the sensors, starting with machine learning or deep learning, computer vision technologies, or data science. All this are pillars that enable us, or that enable that this vision of an autonomous driving or a driver assistance systems. Okay, so this is one view of how this entire AD technology becomes possible. And if you really see what is driving machine learning, there are two aspects of it. For any machine learning or deep learning system, you should have a huge volume of, or large volume of data. If you don't have enough data, you cannot do machine learning, deep learning, right? So therefore it needs a lot of data, and the data has to be diverse. When I say diverse, it means it should have all examples of all kinds of scenes, or all kinds of possibilities. That's when the machine learning system becomes robust and can be deployed and can be reliably used. So therefore, for any machine learning, deep learning, should have a volume of, it needs a lot, a huge volume of data, and diverse data. So in case of research in academic research in driving autonomous driving systems, there is, for anyone familiar with this, the volume of data is addressed by some of the popular data sets, like in computer science, like the Kitty and the Cityscapes dataset. There are a lot of them. But in diversity, these data sets are not, do not have enough diversity to create a machine learning system that can be deployed or that can be used across the world. These are good for Western world driving conditions, but none of that is useful for the big Asian, or Asian countries, or other countries in the world. So what do I mean by diversity? Right? For example, anyone driving a car would be able to figure out these kind of situations on the roads of India, right? Things that are protruding, things that people walking in between vehicles, and people on the road, right? So people, we humans are able to easily drive, or at least able to drive, sensing these. And if you just imagine, our brains are capable of processing these inputs in real time and able to react, and the driver has brought us safely until today, right? Until now. So therefore, how do we design such systems, keeping in mind the safety of things on the road, or people on the road, and us, right? So this is the kind of diversity. When I say diversity in machine learning, this is the kind of thing I'm talking about here. So this is the now I'll talk about what have we done for for research in road safety with AI and machine learning, right? So we have a lot of people from academia and Intel who have contributed in this work. They just wanted to acknowledge all their input, all their contributions here. So as I mentioned, diversity, a road condition like in India, has odd-shaped vehicles, challenging drivable areas. You cannot drive in places that you can just see, and there could be absence of lanes, and things should be people are still driving. So therefore, designing such systems gets even more difficult. and pedestrians and jaywalkers are quite common in these kind of road situations. Okay. So this is where I bring up the India driving dataset, IDD. It is an outcome of the academic research collaboration with IIIT Hyderabad and Intel. Right, as I mentioned earlier, data is what makes AI possible, which AI systems for better reasoning and actions require a huge volume of data and a variety or diversity of data. And this is enabled by the IDD dataset that we have created. So it is the world's first public dataset of unstructured driving conditions from India. And it is openly available for anyone in the world for research. And our intent was to enable research in AI for driving for unstructured driving conditions, and also for any innovations in safe mobility of people and vehicles in the on the roads. So that was the purpose of creating this dataset. As I mentioned earlier, there are multiple datasets that are available from the Western world, which help the most of the world researchers to create interesting machine learning progresses. That was until 2016. And when we were looking at this problem in 2017, we found that there was no data from road scenes like in India, and so we took a goal of creating twice the size of this data set called Cityscapes, and we wanted to put it out for public for open research. And in 2018, when we released it, and there are multiple other datasets that became popular that are huge in size, but still we are proud to say that we were the first ones to bring up this variety of driving conditions or driving scenarios that are possible through our dataset. So since 2018, we have been having this dataset. There are a lot of users who are using this and finding it useful in their research and making progress. It's been a long journey since our work. So we initially started in 2017, 6 years back in IIIT Hyderabad with the first brainstorming. And we had a small challenge of detecting auto rickshaws from given images in the national conference in 2017. And in 2018, we released the dataset to public, and we also organized a workshop in the Tier 1 international conference called the European Computation Conference, ECV. And we also organized 2 data challenges. We had very well-known speakers, give a keynote at this workshop, and it was very well received. And we followed up with another Tier 1 international conference called the ICCV in 2019, and we again had 4 data challenges this time. And we also had in December of 2019. We realized that not many people had the compute that is necessary for that is required for using IDD. So therefore, we also released a dataset called IDD Lite for anyone with just a laptop would be able to train and learn AI or test AI algorithms. So there is an IDD Lite dataset that we released, and we used this Lite dataset for a data challenge in the national conference in 2019. This is the National Computer Vision, Pattern Recognition, and Image Processing, a graphics conference that happens every year now. So that's 2019. And in 2020, we had another data challenge in the national conference. In 2021, we went to the topmost conference in computation called the Computation CVP, and Computation Pattern Recognition, and we organized a third international workshop again with 5 data challenges this time with the same with the IDD. And it was so we have been pioneering this area of research and taking the message that it is important for AI systems to be aware of the variety of data that is possible in most road conditions. So we are continuing that work, and that's the work that we have done. So people are using this dataset and the data for finding out interesting objects, learning new classes of objects from AI or for their AI algorithms. How do you learn from very small samples of data? All those have been enabled by this dataset. Okay, and this dataset also used by the Niti Aayog's MoveHab challenge in 2018 for especially identifying objects and anomalies on the roads. This dataset was the source of addressing one of the problems. So we have released 5 datasets till now under the umbrella of India Driving Dataset or IDD. The detection has coarse bounding boxes, for example, like that you see here. and it has a label that it is a car, two-wheeler, bike, pedestrian. So anyone wanting to, so given an, for an image like this, would have corresponding bounding boxes. So you can write algorithms or learn AI, machine learning systems to of identifying, instead of finding cats and dogs. I would urge that students can learn, really, learn about objects that are really out there in the real world. And the next one is IDD segmentation, which has a pixel level labeling of images on the road. For example, in this image, instead of a bounding box or a rectangle, which just gives you the XY coordinates of this rectangle, we have a pixel level labeling, which says that this pixel is a car, this pixel is a person, this pixel is a motorcycle, this pixel is a road, this pixel is a road object, all those things. So we have over 20,000 images which are with this fine semantic segmentation annotation, right? We also give the train test validation splits from different kind of road sequences. So these are the two things that are quite popular in the computer science community: detection and segmentation tasks. That was some time back. Now the things have progressed since then. So these are the two initial datasets we released. We followed it up with a multimodal dataset which has 6 cameras and or a stereo camera images, the GPS data and a 16-channel LiDAR data. This does not have any annotation. But still this is available for any of your research. And as I mentioned earlier, IDD Lite is a dataset meant for use in resource constrained setup. If you don't have access to a high compute cluster or compute facility, you can use this dataset on your own laptop with a simple CPU with a very small subset, and you would be able to learn or play with AI machine learning algorithms. For anyone interested in temporal analysis, there is another dataset called the temporal, which has annotations about a frame. So for example, this is an annotation for raw image. We have given plus or minus or the adjacent frames plus or minus 15 frames. If you want to identify, or if you are interested in finding out how did the vehicle move, right? For that kind of analytics, this IDD temporal dataset is useful. All these datasets are available for everyone or anyone in the world to download. This is the link to download. Okay, so I want to ask this question, right? It's about 40 minutes. I wanted to pose this question in front of you all, asking how can we, right, researchers or academics and others, through our research, participate or contribute to help save lives and hence contribute to the road safety in India or safety in India or worldwide, right? With that, I want to close this, summarizing, saying that I hope through in this 40 minutes I have convinced you that road safety is a societal problem for the world and us in India in particular, right? And road conditions which are unstructured like in India are a big source of interesting research problems to work on. Okay, and we can use AI and machine learning to solve practical problems in perception and navigation, right? And for that, IDD is one resource which is free, open, and available for global research, anywhere. So we should, I urge you to take a look at it. Right? So the single message that I want to leave with you is solving real world problems can eventually lead to better systems for everyone. If not for us now, it will lead us to the better future. Okay. So the call to action, if you are a student, is pick interesting problems for your work or research and then publish. And if you are a faculty, I urge you to look at guide students who can solve socially relevant and real world problems. Right. That's pretty much it. Thank you very much. And this is the link where you can download the Dataset India IDD. I'll pause here. I'll stop here and take any questions.
If you have any questions, means you can ask.
Excuse me, sir.
Yeah, go ahead. Good start. Go ahead.
I asked something about motivation. Sir, something about the road. I have some doubt about that.
Okay.
What if a sudden turning happens? How the AI can handle that, sir?
Yeah. So the uh, so if there is a sudden vehicle coming in the way, so it depends on the if the question is how can a vehicle handle, the vehicle can handle only if the system or the sensors are capable of sensing such a change in short time, and if the compute or the cpu gpu on the system is fast enough to detect that and then give control to the vehicle, only then it can only then it can avoid or avert such a possible collision. And there have been instances where you would read the news that there have been some accidents where Tesla was where this vehicle was involved, and those are few and far, right, compared to the number of kilometers or miles that the vehicle has driven. The accident that have happened are fairly less, and mm, yeah, we will have to accept it. So if you are asking how can you do it, it is a longer answer. It requires both it requires perception, planning, and control.
Sir, in such scenarios, who is responsibility, sir? Happening accidents.
Sorry, I did not hear it. Can you repeat it?
Sir, in such scenarios, who is the responsible, sir?
Oh, who's responsible? Okay. So I did not talk about that. I wanted to be a technologist, and I wanted to just keep the talk to the technology, on the technology part of it. There are, debates that are happening on who is responsible, right? I do not have an answer for that, and I cannot answer because is it the person who came in front of the vehicle, is he or she responsible, or is the vehicle owner responsible, or is the the or is the responsibility with the algorithm developer, the AI ML algorithm developer, right? Or is the car manufacturer, right? Who's responsible? The debate is still unanswered. So if you are interested, take a look at this wagon problem. This is quite common, and there are philosophers who can argue one way or the other. Okay, so there is no settled answer for that. Who's responsible? Yeah,
Okay, thank you so
the
much.
trolley problem or the
Any other
wagon
query,
problem.
students?
Yes, there is someone who has raised a hand.
Thank you, sir. Vote of thanks by Hosni.
I'm honored to thank our chief guest, Dr. Anbumani Subramanian. Your kind presence in the program encouraged us a lot and made us more confident. It was a great pleasure for joining us today. And special thanks to Dr. I. Manju, ma'am, IQSC, Head of EC Department, for arranging this wonderful section. And thanks to all the students and faculty members. Thank you.
Thank you. So there is one question from Girish, right? Who's asking,
Yes,
will
sir. As in chat box.
yeah, in the chat box. No, Girish, AI will not take over, driver's job. Okay. So this is what, everyone said that computers will take their jobs, right? Maybe, 10, 20 years back when the, banks and all were computerized. This is what everyone said about that. No, AI will not, take over driver's job, right? People will tend to, as technology progresses in the world, you will see that people tend to migrate or go up in the value chain. So don't worry, AI will not take away jobs. The repeatable, the low energy tasks could be replaced by AI, but not by tasks or human intelligence is required. Don't worry. Okay. Okay. Thank you all. Bye. Thank you.
Thank you, sir.
Thank you. Bye. I will sign off.
Ma'am.